Alright, in this video we are going to discuss the changes in the vocabulary of graph theory that we need to make in order to cover digraphs. So this is the digraph vocabulary lesson. Now, here we have a directed graph with 5 vertices. We, in a graph, have vertices and edges, but with a directed graph we no longer refer to the edges as edges. We now call them arcs. So we now call them arcs. And like in geometry, where you name a ray with the starting point and then some other point on the ray, for an arc, we are required to name that arc with the starting point and the ending point. So let's say we looked at arc AB, and we will highlight arc AB with the color green in our graph. AB starts at A and ends at B. So there's arc AB. Okay? In arc AB, notice that we are starting at A and we are ending at B. Okay? So there is new vocabulary related to this. What we say is that A is incident to B, and B is incident from A. The way I like to put it is A points at B, so A is incident to B, and B is pointed at by A, so B is incident from A. Let's look at one more example of this. Let's go with arc CD, which we will highlight. We'll highlight it in, let's go yellow. Okay, so arc CD, that arc right there. That is the arc that starts at C. That's why C comes first in the name. And it ends at D. Remember that you have to name it starting point first. If you said arc DC, you would be incorrect. In this case, C is incident to D, and D is incident from C. So that should cover incident to, incident from, and how to name an arc in a digraph. Moving on to the next little bit, same digraph. We do have adjacent as a term still in directed graphs, but it is not the same adjacent. If we have this case, AB is adjacent to arc BD, but BD is not adjacent to arc AB. Alright, so that takes care of adjacent. Remember that adjacent now is going to mean it ends where the next arc begins. So the reason why AB is adjacent to BD is that AB ends where BD begins. But it doesn't work the other way around because BD ends over here at D, so it is not adjacent to AB, which starts at A. To be adjacent, an arc must end where the next arc begins. So we have a couple questions down here to reinforce that. Down here at the bottom we're referring to an arc AC, so let's get that highlighted in our graph. AC is this arc right here. It says, which arcs is arc AC adjacent to? So AC ends at C. So it would be adjacent to any arc that begins at C. So there are 3 arcs that begin at C. CA, CE, and CD. Remember that again, since it ends at C, any arc that begins at C, it would be adjacent to. Then it says what arcs are adjacent to arc AC. Well, that would be any arc that ends at A. So that would be CA and EA. Again, in order to be adjacent to another arc, the arc must end where the arc in question begins. Okay. Next up, we have degree still. However, there are now two different forms of degree. We have what are called the in degree and the out degree for each vertex. And if we add the in degree and the out degree together, we get the degree. So degree total, which we remember from our other forms of graph theory, is the sum of our in degree and our out degree. Okay, so the in degree is the number of arcs that end at that vertex, that go into the vertex, hence in degree. And the out degree is the number of arcs which start at a vertex. So let's go through this graph and we'll write down the in degree and the out degree of each vertex, and hopefully that will be enough to reinforce this material. So let's locate vertex A. The in degree of vertex A, there are two arcs that end at A. So it has an in degree of 2. Also at A, there are two arcs that begin, 1, 2. So its out degree is 2. Notice that that means there are a total of 4 arcs, either beginning or ending at A. So the total degree would be 4, because the in degree plus the out degree equals 4. For B, there is one arc going into B, one arc ending at B, and there is one arc beginning at B, one going out. 1 plus 1 gives us a total degree of 2. We're going to finish filling this out. I'm going to go through each of these here. C has one arc going in. D has 3 arcs going in. If my pen will work, there we go. And E has 1 arc going in. In terms of beginning, C has 3 arcs beginning, so its out degree is 3. D has no arcs beginning, so its out degree is 0. And E has 2 arcs beginning, giving it an out degree of 2. So total, we have a degree of 4 on C, a degree of 3 on D, and a degree of 3 on E. Notice that once again, in terms of total degree, the number of odd vertices is an even number. Okay. That is it for new information on digraph vocabulary.